Hello, everybody. Um, so, for today's video, I'm going to be talking about the new topic, which is, as you may have already read from the title, it's going to be about the double slit experiment. Okay, so let's first start off with a little bit of a introduction. Okay, so historically, scientists thought that light is light. Okay, and matter is matter. The scientists, from my own understanding, assumed that these two things are independent of each other, okay? Until this double slit experiment came to be, okay? Before this double slit experiment happened, the general consensus with scientists was that light is just made of particles, okay? That was Newton's Isaac Newton's way of viewing uh, light, okay? Until this guy that you see in the picture here, his name was Thomas Young. Thomas Young, okay? In 1801, he created the first ever double slit experiment. And what he did was he had a cardboard, okay? I'm not really sure if it was a cardboard or just a card, but it is some sort of material that had basically these slits on them. And what he did, okay, he was he was standing near a window. You could imagine this is a window, okay? Okay. And he had sort of a black surface here, okay? And what happened was when light strike that, okay? When light strike those slits, okay? What the interesting part was in this black surface, okay? That light that passed through the slit of this card. So what happened was in that black surface, okay, the light didn't just appear on one side, okay? It didn't just appear on one. It didn't just appear on the side. There wasn't just one sort of sort of how do I say this? There wasn't just one slit that appeared when the light struck that single slit on the card right here. There wasn't just one slit. Instead, okay, what he found was there were multiple slits that appeared from that one slit on the cardboard, and on the sides, okay, those slits that this black surface had detected, on the sides they basically just got darker and darker. Okay, no, 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 they basically, the first slit that appeared, okay, from the pattern is bright, but the others were just a little bit more darker. Okay, so this concludes them. This concluded Thomas Young. Okay, Thomas Young. He basically said that he concluded from this experiment, that the double slit experiment, that light not only behaves, okay, as particles. No, let me just correct that, okay? We just correct that. That light behaves as waves, okay? Light behaves as waves, okay? And then we go to Albert Einstein. In 1905, he basically conducted this experiment called the. He basically discovered the photoelectric effect. And how we can think about the photoelectric effect is basically very simple, okay? So if you can imagine, we have a metal object right here, okay? Let me just do that again. So if you can imagine, we have a metal object. Okay, so we have a metal object. Inside that, if you zoom in on that metal object, you could see tiny, tiny electrons that make up this metal object. Okay, and what Albert Einstein basically found and discovered is that when you hit light, okay, when you hit a light that has enough energy, okay, that has enough energy in them, and hit the metal object, the electrons actually get knocked off of the metal object. So you basically have the sort of this sort of pattern wherein the electrons are being extracted from the metal out of this light wave. Okay, and what Albert Einstein basically concluded from this experiment is that he basically discovered that, okay, that light does indeed behave like particles. Okay, and why is that? Because if you zoom in on a light, okay, let's say this is a light. Inside that light, there is little pieces of photons in them. And these photons are basically particles that are inside light, but they are completely massless. Okay, you're completely massless. What I mean by massless is, okay, they have no weight. They have no weight, okay, or any shape or form. They're just there, but they are particles, okay. And what this after this, okay, what led scientists to believe is that and conclude that there is, okay, what we call wave particle duality. So light does not only behave as a wave, but as a particle as well. And modern scientists did this. They redid this double slit experiment, okay? They found, okay, they found that, okay, so you can imagine this is a more advanced version of the card you saw earlier with the two slits on them. And the scientists basically, so you can imagine this is a laser, okay? Let me just, so this is a laser. And when they fired light through those, no. They redid this double slit experiment, but instead of light, okay, they had electrons. So electrons were basically firing through those slits, okay. They basically sort of had this black surface again. They noticed that the electrons, instead of pile, okay, when you observe them, okay, when you observe those electrons, they're basically piling up on this one single sort of single file line that coincides with the slit, okay. But when the thing that they realized, okay, when they put what we call a detector, okay, they put a detector on that card, okay, with the double slits, with the two slits. They found that in this surface, okay, even though they were firing the electrons at just a single slit, they found that the surface was making this very same pattern, okay, this very same sort of pattern as it did in Thomas Young's experiment, okay. So that led them to believe that electrons behave as waves as well, as waves, as both waves and particles. And the same is true, okay? The same is true for protons as well. So protons, electrons, and light, they all are waves and particles, okay? Wave particle duality, the double slit experiment. That's basically what they got from this, okay? So this, from this little experiment that they did, they were basically able to provide the groundwork, provide the groundwork in order for us to create a lot of the things that we have today, a lot of the new inventions that we have today, like for example, the transistor, okay? These little microchips that are inside our phones right now, okay? We also have MRIs, quantum computers, okay? And what I forgot to mention was that, okay, Whenever you observe, what the scientists, whenever they observe the electrons or photons, okay, or the light, whenever they observe that, the electrons, okay, they behaved as particles. But when they didn't observe that, the electrons, light, and protons, etc., they behaved as waves, okay? Okay? So that was the one of the biggest mysteries that has sort of this is one of the biggest mysteries that scientists stumble upon when it came to quantum physics, okay? And that was what Richard Feynman said, okay? So we could conclude that from this, okay, from the quantum state, okay, if we zoom in just enough to see the quantum states, they basically just operate on probabilities, okay? So this really coincides with the Schrodinger's cat, the concept of Schrodinger's cat. I'm actually going to explain that in the next video because that's very interesting. I think that's very interesting. So this is the double slit experiment, you know. So if you guys learned anything, please give me a thumbs up and subscribe to my channel. If you have any feedback, please comment. Thank you very much for watching this video. See you guys in the next video.